Well, I knew that class session last night was going to go quickly. It went even more quickly than I anticipated. And I left you short of an exercise on elasticity. And I hope you pause this at the appropriate time. I'll try to remember to remind you. But right after I give you the problem I was going to give teams last night, if you just pause it and try to do it before starting up and watching me do it, I think you'll learn a lot more from that exercise. Anyway, economists use this concept of price elasticity of demand to keep track of how responsive people's quantity demanded is to changes in price. So we're talking, remember from this screencast before class, we're talking about movements along a single demand curve. So only prices changing. We're studying how quantity demanded responds to changes in price. And the basic relationship is just the percent change in quantity demanded divided by the percent change in price. And, it's a ratio of 2% changes. It's perfectly equivalent to think about it, ratio of two proportional changes. So the key thing to remember is that the proportional change in quantity, I call it delta Q over Q, is in the numerator, and we take the ratio of the proportionate change in price, is the incremental change in price divided by the level of price, that's in the denominator. Just to give you some examples, I had these in the slides that I'll put up shortly. Notice something like salt is, people's demand for salt just isn't very responsive to changes in price. And salt, just takes up such a tiny fraction of people's disposable income, the money they have to spend on stuff, that people aren't real responsive to changes in the quantity of, changes in the price of salt. So before I was married, I had a canister of salt that I bought for 77 cents in 1984. That sucker was 2/3 full when I met my wife in 1992. And, if I had paid $1.50 instead of 77 cents for, 10 years worth of salt, so what? You're not going to think about it. And when things are such a small share of income, we tend not to be very responsive. Coffee's on the list. I'm looking at non-health. Coffee, I'm an addict, and, price of coffee has to go up pretty high before I'd switch to tea. And so in the short run especially, people are really unresponsive to changes in prices of things that they're somewhat addicted to. Maybe you drink Folgers instead of, Starbucks coffee, but you're still going to have that coffee. Movies, I'm actually a little surprised that movies show that low of a price elasticity of demand. But on the other hand, look, some of these data are from 93, and that might have been before DVDs and DVRs and all that, home theater systems became so popular. There's a lot more substitutes now than there were way back when to movies. So I bet if we were to estimate that in a current period, you'd get something closer to negative 2.0, something like that. And indeed, restaurant meals, you got to eat food, but eating out tends to be something we do when we can afford it, and when we're going to tighten up our budgets, we do it by eating out less. So we see a fairly responsive demand for restaurant meals. And the way we would interpret any of these, we would say a 1% increase in price would lead to a 2.3% decline in the quantity demanded of restaurant meals. And for salt, it would be a 1% increase in price leads to a 0.1, a 1/10 reduction in the quantity demanded of salt. So that's how we talk about it. Or you could say perfectly equivalently, a 1% drop in price leads to a 2.3% increase in restaurant meal demand. That's fine. Technically, it's quantity demanded, but I'm not going to emphasize that distinction. Finally, I have no idea what's going on here. The demand for fresh tomatoes, according to this reported estimate, a 1% increase in the price of fresh tomatoes leads to a 4.6% drop in the quantity demanded. I would look at my data and think there must be something going on there, because that just doesn't, that seems an overly large reaction, especially if they're good fresh tomatoes in season. Well, anyway, let me show you about the mechanics of the elasticity of demand, and I've got one of those things on the homework set that I'm going to post hopefully in just a couple hours up on Moodle, due the end of next week. I guess a week and a half from today. All right, so here's the application exercise I had ready for you, and I've just canned these numbers. Let's suppose Teresa's copay jumps from 20 to 40 per doctor visit, and let's say nothing else changes. She's got exactly the same health conditions, same income, everything, but the number of her annual doctor's visits fell from 4 visits per year to 3 visits per year. And then I'm asking you, what is her price elasticity of demand for doctor's office visits? And I'm giving you, as the text does, the restriction that you need to use the ARC price, also known as the midpoint method, to calculate elasticities. And this is something we do when price changes and quantity changes are relatively large. So here price has doubled, quantity has gone down. The traditional way of measuring it would be by 25%. Those are big changes, so the midpoint method is the appropriate way. I guess I could give you a little picture. You're dying to see a graph, I know it. Basically, when we talk about elasticity, in this case we're seeing an increase in price, so I'll draw it that way. Price starts low, quantity demanded starts relatively high, and what we see here, I'll change the color. Price jumps by a lot, and quantity falls also by a fair amount. Not drawn to scale, right? So notice that as we move from this point to this point, we're moving along this stretch of the demand curve. And really, we're talking about a characteristic of this portion of the demand curve. And if we're going to use the base as Q0 or the base as Q1, we're going to get a distorted picture of what things look like. So we're going to use as our base the midpoint between Q1 and Q0, the midpoint between P1 and P0, which is more appropriate when we're looking at big swaths of the demand curve. When you're just talking like a 1% change in price, using the midpoint method isn't that important, but it is when you're talking big changes. And so when we're talking about the RAND study, remember that the one group had free access to health care, first dollar coverage, 100%, and there were several different groups, 25% copay, 50% copay, 95% copay. So we're looking at really big jumps in price. That's why they're emphasizing the midpoint method is not just to torture students. All right. This would be a good time to pause the screencast and get out a piece of scratch paper and see if you can do this on your own. And remember that the midpoint method refers to which number we use for the base quantity and the base price in the denominators of the two proportional changes in elasticities. So go ahead and pause it, give it a try, and then come back and I'll get to it. All right, I hope you did get a chance to work this out yourself. Let me show you numerically how we do this. I'll then show you the formula a little bit backwards, but I want to try to convince you that the numbers aren't that bad if we just think through it with common sense, remembering midpoint. I call it midpoint method because it's a little easier to remember what that means compared to ARC price, with the terminology this text used. Most texts say midpoint method. All right, so it's going to be the proportionate change in quantity in the numerator, proportionate change in price. We're going to use the midpoint method. So let's just crank. The original quantity demanded was 4. The new one was 3. So all right, I just backed up and I think I chopped myself up, but hopefully we take the new level of quantity demanded, that's 3. We subtract off the starting level, that was 4. So that's the incremental change in quantity demanded. We divide by the base level of quantity. Now, typically we divide by 4 if we were doing an approximation, but to be a little bit more precise, we would use the midpoint between 3 and 4, and that's simply 3.5. That's the numerator, that whole lumpy mess. And then we divide through by the incremental change in price. It went from 20 to 40. So the jump was 40 minus 20, positive 20. And then the midpoint between 20 and 40 is 30. Now I did all this with my calculator. When you plunk negative 1 divided by 3.5 into your calculator, you get negative 0.286. And when you plunk 10 divided by 30, 20 divided by 30, you get 2/3, which is, of course, positive 0.667. And then when you take that ratio, you get negative 0.429. I've got this written neatly on the next page. Now the formula, that's all you do. You know, I say that's all you do. I know that this can be a struggle. But that's how it's done. And notice I'm just using the midpoints as the base. It's not that hard to take a midpoint. It is hard. When you write this all out, you get a mess. The incremental change in quantity is Q1 minus Q naught, the new quantity level minus the old quantity. And keep track of sign. It's important. This was equal to negative 1 over 3.5. You got to keep track of the sign. And then I see I said it right, but I wrote it wrong. It's not Q1 minus Q1. That would always be 0, right? It's Q1 minus your base level, Q naught. And then we divide that by the midpoint. And when you think about the midpoint between 3 and 4, oh yeah, that's 3.5. Well, when you write it out, it looks messy, and that I think is part of the problem with these elasticities for students, that the midpoint formula looks so ungainly. This Q naught plus Q1 divided by 2, but for most numbers, just we can do that calculation in our head. We look at the distance between one number and the other, and the next, divide that distance by 2, and add it to the original number, and we've got our midpoint. And most of us don't need this ugly formula that tends to confuse students, frankly. But anyway, this is in the book, and this is where I just wanted to write it out and talk through it so you know where it comes from. P1 minus P naught divided by P naught plus P1 divided by 2. But if you look at a number 20 and 40, and you ask yourself what's the midpoint, you're not going to need a formula to tell you that it's 30, and most problems are like that. Most problems that I'll give you in a test situation are like that. In the real world, obviously, price might go from $2.73 to $3.02, $3.02, and it's a messy world we live in. But we have calculators, and it's not that big a deal. All right, and then I wrote out that answer. And this is just what I wrote before, just a little more neatly. And there you have it. Give yourself, you can make yourself practice problems. Just remember, if price goes up, quantity demanded goes down. Price goes down, quantity demanded goes up. Law of demand. Price and quantity demanded move in opposite directions.